Okay, this is lesson 23 on variables. This is a continuation of one of the previous lessons where we talked about variables. So first try the warm-up and see what you get. Okay, so the first problem, I have 47 bulbs of flowers and I want to plant into 6 rows. So that sounds like division. So you are doing 47 divided by 6 in this problem. So I'm going to do this by thinking of multiples of 6. So multiples of 6 are 6, 12, 18, 24, 30, 36, I'm going to run out of room, 42, 48. So it's going to be somewhere in between here and here, right? So I'm going to write up here, this was 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5, 6 times 6, 6 times 7. So I can make 7 rows with 47 minus 42, 5 flowers left over. I'm just going to say 5 remainder. Okay, there are 369 families in the club. If each family donates $6 to the spring fundraiser, how much total will be raised? Now this is a multiplication problem. I'm not taking this 369 and dividing it up into 6. Each of these are worth $6. So this is a multiplication problem. So 369 times 6. I'm going to skip doing out that multiplication and just give you the answer, which is $2,214. So if you didn't get that, go back and check. James made a batch of 16 cookies. He ate a quarter of the batch. How many cookies did he eat? Now, there's a bunch of different ways you could do this. You could see this as a divide by 4 problem. 16 divided by 4 is 4 cookies. You could have also seen it as multiplication, which is awesome if you saw it both ways, as 16 times 1/4, which is also 4 cookies. When you're dealing with fractions, you are actually talking about division, so it's great. Either way you saw it is awesome. Okay, so we're going to talk about variables, and a variable is for when you want to express a pattern, then you use a letter so that you're talking about lots of different solutions. So here's an example. I ate 3 less donuts than Nick. Do you have any idea how many donuts Nick ate or how many donuts I ate? No, right? But you just know that the difference between the two is 3. So let's make a little table. First is going to be number of donuts Nick ate. And the other column is going to be number of donuts I ate. Let's say that he ate 6 donuts. How many did I eat in that case? Hold on, why is this so blurry? I think I need a film director. If he ate 6 donuts, then I ate 3 less than that, or 3 donuts, right? And if he ate 5 donuts, then I ate 3 less than that, which would be 2 donuts. And if he ate 4 donuts, then I ate 1 donut. So you see there's like a lot of different solutions I could have here. Maybe Nick ate 20 donuts, in which case I ate 17. Now we're going to put a variable in, let's say lowercase n. And what that means is this can stand for any number I want it to stand for. Any number in this column. Maybe it's 20, maybe it's 100. But whatever it is, I can use it to figure out this one. So if this is n, what do I need to do to n to write this column? I need to subtract 3. So if this is n minus 3. So I could say I ate n minus 3 donuts. And now I have a formula. So if I'm then given how many donuts Nick ate, I could use that formula to figure it out. Now this is absurd, but let's say Nick ate 142 donuts. Let's say maybe they were like mini donuts. I can use this formula now to figure out how many I ate. I would take n, or my number, 142, and subtract 3. So I ate 139 donuts. Okay, so try the problem of the day on the front. Where's it? There. Try it first, and then I'll go over it. Okay, Will rollerblades 3 times as much as Sam. If Sam rollerblades S minutes in a day, write an expression for how many minutes Will rollerblades. So I'm going to make a little table just to get some values. Okay, if Sam rollerblades, say, 10 minutes a day, how many minutes does Will rollerblade if it's 3 times as many? So it would be 3 times 10, or 30. Let's say Sam rollerblades 1 minute a day. How many minutes does Will rollerblade? 3 times 1, or 3. Now let's say Sam rollerblades S minutes. I'm going to make another column over here. How would I figure out the number of minutes Will rollerblades? So same idea as here. I would take this Sam column and multiply by 3. So this would be 3 times S. So Will rollerblades 3 times S minutes. Now, is it the same thing to say S times 3? Absolutely. It doesn't matter what order you do the multiplication in. It's also the same thing as just saying 3S right next to each other like that. All those are great answers. Okay, Maggie rollerbladed half a mile longer than Claire. If Claire rollerbladed C miles, write an expression for how far Maggie rollerbladed. So let's make another table. Okay, so let's say, I'm going to start on the Maggie side this time. Let's say, or actually I'm going to start on the Claire side because it tells us to use Claire as our variable. So let's say Claire rollerbladed 1 mile. That's pretty far. Then Maggie would have rollerbladed a half a mile longer, so 1.5 or 1.5. Let's say Claire rollerbladed 2 miles. Then Maggie rollerbladed 2.5 miles. So you can start to see the pattern. So if Claire rollerbladed C miles, how would I figure out Maggie's? I would do C plus a half. So I could say Maggie rollerbladed C plus a half miles. And is it that the same thing as 1/2 plus C? Absolutely. It doesn't matter what order you write addition in. It's the same thing. Okay, last problem. Solve for P in the equation below. So 3032 divided by P equals 8. So if you're thinking to yourself, oh, I'm going to try and do this by making P groups and then sorting it into P groups, well, that's going to be really tricky because we don't know what P is. So there's a couple of different ways you might think of this. You might think of this in terms of a fact family, where this is 3032, this is P, and this is 8, and we're talking about multiplication division. So in that case, if I think of it this way, 3032 divided by P is 8, but it's also true that 3032 divided by 8 is P. And this I can do because all the numbers are on the same side together. So 3032, I'm going to do it, let me see, over here where I have some room. So I'm going to do it using the 7 method. 3032. So, what's the biggest number I can think of? Well, I'm going to do, I can't do 8 times 1,000. 8,000 would be too big, but I can do 8 times 100. 8 times 100 is 800. And now I'm going to subtract to see how much I have left to use. Oops, what am I doing here? 10, 2. Okay. This time I think I'm going to do maybe I don't want to get too big. Maybe I'll do 200 this time. So 8 times 200 would be 16 with 2 zeros. Now I'm going to subtract 2, 3, so 632. I'm going to use my math facts to think 8 going into 60. Well, let's see. 8 times 8 is 64, so that would be too big. So let's do 8 times 70. 8 times 7 is 56 with an extra 0. So I'm going to get 2, 52. And so I'm going to do 8 times 6 because that's 48. And I get a remainder of, I think I did something wrong because I don't think I was supposed to get a remainder. I get a remainder of 4. So I've got 376 with a remainder of 4. I did something wrong somewhere. Unless I got the wrong answer the last time. Okay, I think the answer to this is 379. That's what I got the last time I did it. So I did something wrong. If you can figure out what I did wrong, then you win the gold medal. 800, 2, 3, 2, 2. And then 1600, 2, 3, 6, 0. Okay, that one's right. 10 times 7 is 56. 2. Oh, there we go. 13 minus 6 is not 5. 13 minus 6 is 7. There's my mistake. 72. And 8 goes into 72 9 times. So it is, when I add these up, I get 379. So P equals 379. Okay. Oh, geez. All that was off camera, wasn't it? Sorry about that. So when I do this division, I get 379. Okay, write a word problem for the equation above. Obviously, everybody's word problems can be different, but let's say I have $3,032, and I want to split it among P people so that each person gets $8. So we get the answer P is 379 people. If you're not sure if your word problem works for it, then just send me a little video and I can tell you if it works or not. Okay, have a great day.